All right, for this video, what we're going to look at is the genes themselves and how they are expressed. So we're going to look at single genes, and then we're going to look at multi-genes. So we'll talk about single gene effects on development, and we've talked about honeybees, and one of their phases that they go through is being ones that clean out the nests, and it's kind of complex. And so what I want you to know is there are what we call hygienic versus unhygienic bees. And so when they go in and they clean out these cells, what we have found out, there are actually two different genes that are responsible for doing that. And the behavior is uncap and remove. And they have to have both these genes to do it. So what they did is they messed with these and found out that there are certain bees that will uncap and remove any dead pupa that's inside, and that would be a hygienic bee. But there's also some bees that only have the uncap gene. So they'll go on and uncap it, but they won't actually remove the larvae that's dead within. There are also some bees that only have the remove gene, so they will not uncap it. But if one comes uncapped and there is something dead in there, they will take it out. And they've done studies where this is exactly what you see. It's we would call a dihybrid cross, where you see a certain amount that do both, and that would be I don't care about the ratio, but it's a 9 to 3 to 3 to 1. So 9 out of 16 of them will be hygienic. 3 of them will actually uncap and not remove. 3 of them would remove but not uncap, and then there's a group that doesn't do anything. They're useless. But anyway, so kind of interesting. These are just a single genes, but we know now there are 2 of them necessary for being hygienic. And then there's another study where they have a single, and they call them knockout genes, where they go in and they physically turn them off, they damage them. And so the one very famous one in '96 was the FOSB gene. Now mice and dogs and cats will do this, is the parent will go out and actually, if the young kind of crawl away, they will collect them and bring them back. It is the FOSB gene that is that instinct for them to do that. And so what happens is that if you knock that out, you will find that the ones with the FOSB gene will go get them and bring them back and cover them, and then the ones that are without the gene won't go. They do not collect their kids. So unless their kids wander back, obviously not great parents. And we've seen that in other animals. Fruit flies is another one they've done it too, because pretty easy to do. Multigenic effects, and what happens is we found that some lovebirds can do hybrids. They're closely related enough where they can actually have offspring. So let's look at these lovebirds. We know that it's more than just one gene, and it has these variations. So a Fisher's lovebird, when they're nesting, they'll take some paper, and you'll see them, and when they carry it, they will actually carry it back to the nest in their beak, and then they'll build their nest. Peach-faced lovebirds, on the other hand, which is a more common pet bird, they actually tuck it in underneath the feathers above their tail, and then they'll fly with it back there and then put it in the nest. Now the hybrid is pretty entertaining, because what happens is you will see that it takes the strip, and then they try to tuck it. In other words, they got that gene in there from the peach-faced lovebird, but they aren't very successful at it. So what happens is they end up flying it with in their beak, like the Fisher's lovebird. But what you will see as it goes on is that the hybrid bird, the lovebird, will find out that it's not effective. So why do it? But they still have the tick. You will still see them kind of bend their head toward their tail. So genetically, we know that trait's still there, but they have learned that it's not very functional. And so they will kind of avoid spending a lot of time messing with it. But they will still do that head turn, which is kind of interesting. All right, and then our last study is the very famous rhesus monkey study, and I have put a video up on this for you to watch. And what they did is they reared monkeys, and they had them in different situations. They had one reared in total isolation. They had one with a wire monkey. They had one that was raised in peer groups. One reared with mother only, one with mother, and sometimes they take the baby away. And then they had rearing in small social groups, which is probably the most common, how rhesus monkeys would actually behave. So I do want you to watch that. And the wired monkeys, the ones that were raised by wire monkeys, definitely did not develop socially accurately, and that's a common problem, you know, and so it is that nurture is extremely important, especially in primates and humans, to have that contact. And so I do want you to watch that video. And just to give you examples, gorillas were very rare in zoos at one time, and then breeding in captivity was and still is fairly special. And so zoos used to, the minute a chimp or a gorilla was born, they were pulled for safety. They were taken to a nursery and they were raised by keepers. And then eventually they would be introduced to the family and put back in. But what they found out is that you ended up with a bunch of gorillas and chimps that were socially had issues. And so today's zoos tend to try to keep those with their parents. They've got to the point now where there's a separation from the group, where the mother's kept alone, but within the area. And then they start slowly introducing other gorillas that will, usually other females at first, that will be able to kind of deal with it, and mom protects and build that family unit. Matter of fact, the problem was because all these mothers had been raised in zoos, in nurseries, they actually had to be taught again how to raise their young. It was, they didn't have, you know, learn by watching. And the problem was there was no babies to watch at that time, or no mothers to watch at that time. So it became a huge problem. So, and I joke, I work with somebody, won't name them, and I joked about how raised by a wire monkey, some of the social skills are lacking in this person. You know, it was funny to watch, is when you see somebody, especially for the first time on the day, you say hello. I mean, most people do, and what would happen is you get no acknowledgement. And somebody actually said something to this person, and now this person will say hi to you. But it's funny because I have watched, I love to watch people, is once they say hi, if they see you later in the day, they won't say hi again. It's kind of like, oh, I've checked that off my list. So it's a joke. And then I met this person's parents, and I expected, you know, wire monkey. And it turned out this person's father, immediately I met him and started making fun of me, and I loved it. Great sense of humor. And so I even asked, what's wrong with your kid? But anyway, so that is the wire monkey story. So be sure to watch the video for this. And then we're going to just, again, kind of remind you a couple others that come in here. Behaviorism, behavior results from previous experiences. And that was John Watson. So remember that experiment. And we had the video of little Albert is associated with this. So if you want to rewatch that, just to be sure you understand. And then we have the B.F. Skinner, which is the operant conditioning, which is what was used to reward, or you could punish an animal to do what you wanted to do, stimulus response. So get the bird, the dove in the video was taught to turn in circles. And again, this is what we would use at the bird show, positive reinforcement to get the birds to do what they wanted. And we will stop the show and stop the recording.